So to analyze this particular salt, we have sample C and D. The sample C is actually a salt of lead nitrate, that's BnO32, and the sample D is a sort of potassium sulfate or potassium sulfite, K2SO3. However, you don't know this component of salt, you are expected to analyze them to identify the component ions in each of those salts. So to the first question there, when you heat up sample C, the first thing you're going to observe is going to be crackling sound. You have a crackling sound. You produced, that's one. You're going to have evolution of a reddish brown gas or a release of reddish brown gas. If you have been asked to identify with litmus paper, that gas should turn a moist blue litmus paper to red. Then after that, you are going to have a brown residue. Brown residue is obtained when it's still hot. So your inference for that, for the reddish brown gas, the gas is NO2. The gas is NO2. However, it's not the gas itself you are testing for. You want to identify the anion. So that NO2 indicates that it is coming from the presence of NO3 minus in that salt. So if you have used a litmus paper, you are going to state as inference that the gas is acidic because it will have turned moist blue litmus paper to red. So when the residue is allowed to cool, remember when it is hot, the color of the residue is brown. So the brown residue turns yellow. That's when it is cool, and that's because lead oxide PbO is present. That's a characteristic feature of lead oxide. Now to the next question, the sample C in water, then you stir. By the nature of that salt is a nitrate salt, so it should dissolve completely. The C dissolves completely. So your reference is going to be that C is a soluble salt. Next, when you have the sample C and then you added freshly prepared iron to sulfate, after which you pour gradually down the side of your test tube a solution of concentrated H2SO4, you are going to have a brown ring formed. Brown ring will be formed around the junction of the two solutions you have in that your test tube. So that's the confirmatory test for nitrate ion. So NO3 minus is confirmed. Further, on the portion of the B1 that you have, that is the solution of sample C, you add sodium hydroxide in drops. In drops, you are supposed to have a white, you're going to have a white non-gelatinous, or you can just say chalky precipitates. That's what you're going to have in drops. And the inference for that is going to be either calcium ion or lead ion is present. Then when you add in excess, the precipitate dissolves, or you say the precipitate is soluble in excess sodium hydroxide. That is for only lead ion is going to be soluble in excess of sodium hydroxide. Now to the next question, when you add ammonia in drops, you are still going to have white non-gelatinous precipitate. And when you add the sodium hydroxide in excess, the precipitate will also dissolve. So at first, when you add in drops and you have your white gelatinous, non-gelatinous precipitate, that is still going to be either Ca2 plus or Pb2 plus is present. And when it dissolves in excess, that is only also for Pb2 plus. Now, to the portion of the B1 again, that is the solution of sample B, sample C. You are adding dilute HCl, then you heat it up. When you first add your dilute HCl, you are going to have white precipitate. This time around, you are not saying gelatinous or non-gelatinous, just a white precipitate is formed. Okay, when you heat it up, the precipitate will dissolve when you heat it up. This is when you are heating, precipitate dissolves when it is heated up. And when you allow that hot solution to cool down, then the precipitate will reappear. So when you have this kind of observation, then it is because at first Pb2 plus is present. So when that precipitate reappears, that's a confirmatory test for lead ion. So now we want to analyze the sample D. Don't forget your sample D is actually K2SO3. By nature, the potassium ion cannot be analyzed using a reagent. So what we use is the flame test. So you could be told to take maybe a spatula or a stirring rod, dip it inside the solution of that particular salt, and place it over the bouncing flame. So the effect of that particular salt on the flame will give us a characteristic color. So what you're going to observe in this case is going to be a lilac colored flame to be produced. That lilac color of the flame is a test for potassium ion. So potassium ion is present. For the sample D again, you add some water, then you stir. When you add water to sample D, being a potassium salt, is going to be soluble in water. So to dissolves completely. The inference for that is going to be that D is a soluble salt. Then when you test with litmus, for the fact that the salt is a salt that is formed from a combination of a strong base and a weak acid, so you should expect the litmus to turn red to blue. Thus, the inference for that is going to be that solution of D is basic. It's a basic solution. Now, when you take the solution obtained above and you add barium chloride, you are going to have white precipitate formed. That white precipitate, the inference for that is going to be that you have either CO32 minus or SO42 minus or SO32 minus present. Now, when you add excess HCl, if that white precipitate dissolves, it is soluble, then it's going to be either carbonate ion or the SO32 minus present. But if it is insoluble, then it is SO42 minus. In this case, the precipitate will be soluble. So precipitate dissolves or is soluble. So for this particular one, the inference is going to be CO32 minus or SO32 minus is present. So now, when you take the solution of that particular sample E again and you add drops of acidified KMNO4, if the purple color what you're going to observe here is going to be that the purple color, the KMNO4 acidified, is actually purple in color. So when you add drops of it to the solution of that particular sample, you are going to have that the purple color of the KMNO4 fades, or better say you say it decolorizes. It decolorizes. So that test shows that you have a reducing agent is present. Reducing agent is present, and between the CO32 minus and SO32 minus, we are suspecting. So it's going to be SO32 minus that is present, because that SO32 minus can be oxidized further to SO42 minus, which is not possible for CO32 minus. So that's all about the analysis of the salt.
Welcome to our lab of wonder and delight, where learning's fun and knowledge takes flight tonight.